All right, here we go, learning about how to actually name and then draw alkanes. So alkanes are hydrocarbons that have single bonds between carbons. So we don't have any double bonds, any triple bonds. It is only single bonds. In your workbook, you have these notes. So there isn't even a separate notes package for organic that you have to look at. It's all in the book, which is really perfect for this format. Now, here's the thing about the notes for this. It's very much like, do this and then do this in steps. It's very wordy. It's probably good to try to go back and figure out, oh, which way do I do this? And then you could read through a part of it to figure it out. But most of your learning for this topic is going to happen from the examples by showing you the process. That's where you're going to learn. Okay. So I'm not even going to read the notes to you. I think that's silly. You have them. I will talk about it. Okay, and then we're going to go through examples together, and that's going to be primarily your learning for this. So first of all, what you're going to do is you're going to find the longest continuous chain of carbons. This is kind of almost a puzzle where you have to find, without like lifting up your pen, how many carbons can you connect in a row. That is called your parent chain. It's your longest continuous chain starting at one end and going to the other. Sometimes this chain isn't obvious what your parent chain is, so you need to be very careful to make sure that you are finding the longest chain, because sometimes it might go not just side to side, but go up and down and go all, kind of curvy or whatever. But you got to find your longest parent chain. You'll see an example of that in a second. This decides your base name. So depending on how many carbons you have, that will tell you what your base name is for the hydrocarbon. If you have one carbon in that parent chain, it's meth. Okay, if you have two, eth. 3 prop, 4 bute, etc. 9 is nana, right? That kind of thing. So that will tell you your base name for the alkane. Now, the next thing you're going to do is you're going to number your parent chain from 1 to whatever the highest number is for the parent chain. You number it in such a way that you reach the branches as quickly as possible. In other words, on the lowest number as you possibly can. If you have a tie for the first branch that you reach, well, then you need to look at which total for all of the branches would end up being lowest. Okay, so if both directions reach a branch on 2, then I look at the total of both ways going left to right and right to left and figure out which one ends up with a lowest total when I add all the branch positions together. And the lowest total direction or way of numbering is the better one. If you still have a tie, then you go with the numbering that reaches the alphabetically first branch first. And again, you're going to see this in examples, but most examples are going to come down to just actually figuring out which numbering direction. There's only 2 directions, right? You got 2 ends to your parent chain, so left to right or right to left. Which one reaches the branch first? Okay, then from there, you are going to name your branches and you're going to tell the position of those branches. So once you've named or numbered your parent chain, then you're going to say the number that your branch is at and then the name of your branch. Okay, now the name is similar to what you just saw on the previous page. It's methyl ethyl propyl for 1 carbon in the branch, 2 carbons in the branch, or 3 carbons in the branch. We can even get to butyl. We don't normally get past that because then it would be part of the parent chain if I have a really long branch. If I have more than 1 branch, then I add to that a prefix. I list both numbers. So let's say I have a methyl branch on carbon 2 and carbon 3 of my parent chain. I would say dimethyl, but I would actually say 2, 3 dash dimethyl. And then I'd give the parent name. And again, I know that right now this is like, what? This is so confusing. You'll see it. You'll see it. It will make sense. But I want to talk through the notes first. And then you put all the branch names in alphabetical order, not based on the prefix, the di, tri, tetra, but based on the actual branch name, the methyl ethyl propyl. So if you have ethyl branches, that goes first before methyls, for example. All right, but you're going to see all this. It's all going to make sense. Between numbers and letters, I'm always going to place a hyphen. So hyphens are always used between numbers and letters. And then when I have more than 1 number in a row, I need to put a comma between it to show that it's not 1 number. Like if I had 2, I don't want it to be 22. I want 2, 2. So always commas between numbers and always hyphens between numbers and letters. There are never any spaces between words except for way later on, where we'll introduce some spaces for a specific purpose. But for now, it's all one ugly, horrible word, which you're going to see. Alkanes are only single covalent bonds between carbons, and they have the general formula CnH2n plus 2. So if I have an alkane that has, let's say, 5 carbons, well then 2n, so 2 times 5, because 5 is n, is 10 plus 2 is 12. So C5H12. That would be an example of an alkane. If I had C17, that would be H36, right? 17 times 2 is 34, plus 2 is 36. That kind of deal. So let's get into some naming. All right, so this is where you're going to learn it. All those notes before, yeah, here's the actual thing of the learning process is seeing these examples. So here's my first example. I have 1, 2, 3, 4 carbons. They're all in a row. So my longest chain is 1, 2, 3, 4 carbons. I just have a parent chain. I do not have any branches at all. Given that I have 4 carbons in a row, I look at my table and figure out what the name would be. And it's going to be bute, okay, for the name of my parent chain. And then the fact that this is all single bonds between carbons means it's an alkane. So it's going to be butane. Butane. This is the same stuff that's in lighters, butane lighters, okay? So it's 4 carbons in a row, all connected with single bonds, butane. Here's another one. 1, 2, 3, 4, 5, 6, 7. So look at it. What do you think the name would be? And the answer is, because I have 7 of these carbons, this is hept for 7, ane, because it's an alkane, and these are all single bonds. Okay. Oh, I got a branch. So the first thing I need to do is figure out what my longest chain is for C. And it's, of course, going to be 1, 2, 3, 4, 5. Now let's talk about numbering. I could go left to right for this, 1, 2, 3, 4, 5, or changing colors, so fancy. Green. I could go 1, 2, 3, 4, 5. So you got to ask yourself, what's better, the red or the green for the numbering? And the answer is very obviously that the red is better because it reaches a branch at 2 instead of 4. So I want to get to the branches at the lowest number possible. So I want left to right numbering here to get to the branch on 2. This branch is a 1 carbon branch. So that means the branch name is methyl. Now let's deal with my parent chain first. I have 5 carbons in a row. So that is pent, ane, because this is an alkane, all single bonds. Then I have a methyl branch, a 1 carbon branch on the second carbon. So this is 2-methyl pentane, all one word. I have a dash or a hyphen between the 2 and the M, right? Because numbers are separated by letters with a hyphen. So this is 2-methyl pentane. All right, for D, I've got 1, 2, 3, 4, 5, 6. I can get 6 carbons in a row. If I went up from here, I should consider that 2. It's 1, 2, 3, 4, 5, 6. So same. Doesn't matter if I do it from right to left or like this kind of like up and then to the left. Now, if I numbered it from left to right, it would be 1, 2, 3, 4, 5, 6. So right to left is the right way to do it because I reach this branch on 3 instead of 4 if I went from left to right. So this branch has 2 carbons, which means that it is ethyl for the name of the branch, 2 carbons, ethyl. So YL is how I show it's a branch. So this is 3-ethyl, and then 6 carbons, hexane. So 3-ethyl, okay, that's my branch part. Hexane, that's my parent chain part. All right, for E, I'm going to ask you, what is the parent name, the parent chain name for this? And the answer is that it's actually going to be 1, 2, 3, 4, 5, 6 carbons, hexane. This is not a left to right one. I need to consider the longest chain, which is actually going up from the bottom here. It's a tricky one. This one's trying to trick you. So this is a methyl group on carbon number 3. If I went from right to left and then down, right, it would be instead 1, 2, 3, 4, 5, 6. So this is the better numbering, 1, 2, 3, because I reached the branch on 3. So this is 3 methyl hexane. 3 methyl hexane is the name for this one. All right, for F, I get into the realm now of having 2 branches, not just one. So I would go ahead and go 1, 2, 3, 4, 5, 6, 7. I have an ethyl branch right here and another ethyl branch right here. I got 2 ethyls. So this is going to be, and I have to specify the location of both, 3, 4 dash diethyl heptane. So 3, 4 diethyl heptane is my title. Now, I should have talked about the numbering. It is left to right here because right to left it's 1, 2, 3, 4, 5, right? So I reach a branch on 3 from left to right, which is better than reaching a branch on 4 if I go right to left. So 3, 4 diethyl. Di is because I have 2 ethyls, and I should always have this prefix here matching the numbers that are listed before it. Okay, so 3, 4 diethyl heptane is a name for that one. All right, I've got a few more here. Now I get into even more branches. I've got quite a few going on for G. So I've got 1, 2, 3, 4, 5, okay, from my parent chain. So I've got branch, 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 and branch. All of these branches are 1 carbon long, so they're methyls. So I'd end up with 2, 2, 3, 3. And yes, I have to do these in numerical order from lowest to highest. Tetra, methyl, pentane. Okay, why don't you give H a try? It's similar, and see how you do. So for H, I've got 1, 2, 3, 4, 5, 6. Again, going to left to right gets me branches on 2, which is better than right to left. So I have a methyl, a methyl, a methyl, a methyl, a methyl. So many methyls. I have pentamethyl. 5 methyls. So penta, which is the same prefixes we use for molecular compounds here, right? Pentamethyl. Oh, whoa, I'm just so wrong here. Oh, back up the truck. Oh my word. I didn't put my numbers down. Geez, that's what happens when you zone out. I zoned out, I'm not gonna lie. 2, 2, 3, 4, 4. Penta, there we go. Methyl, and hexane, because I have 6 carbons in a row. All right, for I, I'm now getting to something interesting because now I actually have 2 different types of branches going on, which is good that I'm dealing with this. So I got to figure out which way to number this. Should I go left to right or right to left? And I want to go left to right because that gets me to a branch on carbon number 2. So 1, 2, 3, 4, 5, 6. And then that leaves this as a branch and this as a branch. Now, when I list my branches in my name, I have to list the alphabetically first branch first. So ethyl is going to go before methyl, even though in terms of number, branch position, the ethyl is 4 and methyl is 2. That's fine. I go 4 ethyl, because again, E is before M, 2 methyl, hexane. Okay, J is a good one for you to try out. See if you can do that one. Be careful with the parent chain. So answer for this is we would go 1, 2, 3, 4, 5, 6, 7, 8, leaving this as an ethyl branch and this is a methyl branch. A lot of you probably went left to right on this, but again, I need to find the longest possible chain. So be careful with these kind of twisty ones and make sure that you are getting the longest chain. So what I end up with then is 5-ethyl, 3-methyl, octane. K and L is where I'm dealing with some line diagrams, which you have to learn how to name as well. So a little bit trickier, but again, every one of these vertices represents a carbon. So what I have here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have nonane as a base name. I have a methyl group right here. I have an ethyl group, 1, 2 carbons right here, and another ethyl group right over there. I'm going to struggle to find space to name it, so I'm just going to go beside here. So what I have is 3, 5 diethyl. I got to put the ethyls first because alphabetically E is before M. 4 methyl. And then nonane. Nonane. So 3,5 diethyl, 4 methyl nonane. Notice how I put a hyphen between the L and the 4, because again, every single time I have letters going to numbers or numbers to letters, I need to separate that with a hyphen. All right, try L out and see if you can figure out the answer to that one. And the way this goes, and this is actually tricky for numbering. I really like this one because the numbering on this is somewhat complex. So when I look at the numbering, I could go 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I got to erase the previous one here to make space because otherwise it's just kind of a mess. And I'm going to do 2 different sets of numbers here that you can see. So 1, 2, 3, 4, 5, 6, 7, 8. There's the red. And then let's go with green again to show the different set of numbers so you can see this. 1, 2, 3, 4, 5, 6, 7, 8. Between red and green, which set of numbers do you think is the better set of numbers? Both reach 3 at the same point, right? Like both have a branch on 3, but red has a lower total. So if I add together all the branches for red, I should change my color so I can show you this properly. I have 3 plus 4 plus 6, which is equal to 13. And then if I do the same with green, where I have 3 plus 5 plus 6 is equal to 14, this makes it clear that red is the better choice for the numbering. Okay, so we're going to have to go with red for our numbers. Let's get rid of the green. So now if we name this, and I'll do this up here because that's where I have space, I have my ethyl first, so 6-ethyl. And then I have 2 methyl groups, 1, 2 methyls. So 3, 4, oh, sorry, messed up, should have had a comma there. 3, 4, dimethyl octane. Now this brings up an interesting point. And the interesting point is that ethyl is E and it's going before the D in dimethyl. And again, that's because the order has to go alphabetically by the branch name, not by the prefix. So because E comes before M in the alphabet, ethyls are listed before the methyls. So now let's get into drawing hydrocarbons and going into how we actually make the drawing of condensed or the line diagrams and so on. And we're going to get into specifically alkanes. Okay, so how to draw alkanes. So we start off by drawing a straight chain containing the number of carbon atoms represented by the name of the parent chain. So we draw the parent chain first, and we're just going to start by drawing the carbons. Now ignore the 1, 2, 3, 4, etc. That's just tracking how many I have. So you just count it out. 1 carbon, line, 2 carbons, line, 3 carbons, line, etc. Okay, so if you're drawing 2-methyl octane, you would draw out 8 carbons. Now notice that there's a space being left here right before the next line. That's a space that's for the hydrogens that we're going to put in afterwards once we figure out how many hydrogens we need on each carbon. Then what we do is we attach all branches to their numbered locations on the parent chain. So given that we know we're going to be on the second carbon for the methyl, then we put our methyl, our CH3 group right there. After that, we're going to attach all of our hydrogens by counting how many lines or bonds we have to each carbon, and then how many hydrogens we need connected to that carbon to get to 4. So for example, on this N carbon, I have 1 line, so I need 3 hydrogens, because 3 plus the 1 line gives me 4 covalent bonds on that carbon. For this carbon, I have 1, 2, 3 lines, so I need only 1 hydrogen to get to 4. 2 lines here, so I need 2 hydrogens to get to 4, etc. So I just fill out the carbons to get to 4 bonds for all of these. Now we could make, all of these into complex, crazy, curly shapes. We don't want to do that though. What we always want to do is just straight kind of lines. And we want to go normally from left to right for the numbering and just keep it the same all the time, right? So we could like go 1, 2, 3 sideways and go up and another 2 and then to the left and go 3, but that would just be silly and it's hard to read. So we're just always going to go from left to right for our drawings, and then we're going to number from left to right as well, and the parent chain will always be in a line. So let's go through a few examples so you can see the drawings of this and then, see how it goes. So if I have 3,3-dimethylhexane, I would start out by drawing 6 carbons in a row. So 1, okay, leave a space, 2, leave a space, 3, 4, 5, and 6. I have 3,3-dimethyl, so that means that I have a methyl coming off of this carbon, the third one, so a CH3, and then another methyl coming right here, CH3. Okay, now I'm done my carbon kind of skeleton, and now I'm going to fill in my hydrogens. This carbon has 1 bond, so it needs 3 hydrogens. This carbon has 2 bonds, so it needs 2 hydrogens. This carbon already has 1, 2, 3, 4 bonds, so it's done. I don't need any hydrogens there. This one has 2, so 2 hydrogens, 2, so 2 hydrogens, and 1, so 3 hydrogens. And now I'm all set up with my structural formula, my condensed structural formula. If I were to do this as a line structure, I have 1, 2, 3, 4, 5, 6 carbons. So 1, 2, I've already done 2, because remember each point, each vertices is actually a carbon. 3, 4, 5, 6. I always want to go in this kind of like zigzag pattern for this. Okay, so 1, 2, 3, 4, 5, 6. And then I have 2 methyls, so I'm going to draw 2 lines off of the third carbon. And because these 2 are going up, they're going to go down. Oh, didn't want to draw that. Oops. All right. 2, 2, 3, 4, tetramethyl octane. So you could give this one a try, but I'm going to have 8 carbons in a row. So 1, 2, 3, 4, 5, 6, 7, 8. I have methyls on second carbon. 2, 2. On third carbon, 3. And on fourth carbon, 4. It doesn't matter if I put these on the top or the bottom. It's the same, right? I could have drawn these down below. Wouldn't have mattered. Let's fill out our hydrogens now. I have 3 here. I have none here. It's already got 4 bonds. I have 1 here. 1, 2, 3, 4. 1 here. 1, 2, 3, 4. 2 here. 2 here. 2 here. And 3 there. For my line diagram, 1, 2. Oh, ugly. 1, 2, 3, 4. Oh, sorry, 3, 4, 5, 6, 7, 8. 2, 2. So 2, 2, 3, 4. And that's my line diagram for the same thing. All right. So now you're on to the work. You've got a whole bunch of work here of what you can try out, then take a look at the key and see how you're doing. I suggest kind of going back and forth between this and the key. Really helpful to kind of see where you're at and if you're doing things correctly. Okay, so yeah, give it a try. Have a good day. Talk to you later.